Hey everyone, so I'm going to do the review for your test this Friday. This is the calculus review. Alright, so first question. The first question says, if f of x equals the square root of x squared minus 5 and g of x equals x over 2, then what does f of g of 4 equal? Well, this is a composition of functions, and the first thing you should do is the inside. So that means complete g of 4 first. That means plug in 4 for x for g. So this x value got replaced with a 4. And I get 2. Now take this 2 and put it into f of x. So now you'll have f of 2. So everything for the x's here are going to get replaced with 2's. So it's going to be 2 squared minus 5. That'll get you 4 minus 5, which is the square root of negative 1. Now, you should know from algebra 2 that that equals I. But we're not going to accept that in Calc. There aren't any imaginary numbers in Calc. We're just going to state that this is undefined. It's not defined in the real number realm. Alright, next question says, if f of x equals 3 log square root of 2 plus x, then what does f to the negative 1 of x mean? This is the inverse. That's what they're looking for. So to find the inverse, you're going to switch x and y. I'm going to replace f of x with y first. And then I'm going to switch x with y. Now your job at this point is to get the y out of the square root and away from everything else. So you should say to yourself, what can I get rid of first? Well, you can get rid of the 3. X over 3 equals log square root of 2 plus y. Now the y is still inside the square root, so you got to get rid of the log. To get rid of a log, you raise each side to the 10th power. So the 10th is going to go down here, and it'd be 10 to the x over 3. The 10 and the log here will cancel, and you're left with the square root of 2 plus y. Now at this point, you want to get the y alone. The only problem is that there's a square root. To get rid of the square root, just square both sides. Now you have x over 3 on the inside and a 2 on the outside equals 2 plus y. You could bring that 2 inside and get it 10 to the 2x over 3 equals 2 plus y. But ultimately the last thing you need to do is get the y alone by subtracting the 2. So your inverse is equal to 10 to the 2 over 3x. I'll rewrite that because I don't like the way I wrote it. So 2x over 3 minus 2. And this is your final answer. Your next question states, state if the function is even, odd, or neither. Now, function A, if you graphed it, is a sine function with an amplitude of 3. And it would keep on going. So the highest point is 3 and the lowest point is negative 3. This is an odd function because it has symmetry over the origin. Now, for B, this is a parabola that was moved up 5. This has symmetry over the y-axis, so this is an even function. C is an exponential function, and it has no symmetry at all, so it's neither. The next question says, the equation models the equation y equals 6.72 1.014 to the x models the world population y in billions of people x years after the year 2000. Find the year in which the world reaches 8 billion. So I'm going to set y equal to 8 because y represents your population. And from here I'm going to solve for x. X is in your exponent, so logs are going to come into play, but the first thing you should do is get rid of the things from the base and the exponent. That's the first thing you should try to get alone. Getting that alone means dividing by 6.72. When you do that, you get 1.190. Now, keep that whole number inside your calculator so that you keep accuracy when you take the log. At this point, you're going to take the log of both sides in order to bring down the power. So you have log of 1.190. And in this case, you're going to do log of everything that's inside of your calculator. So log 1.014. To get x alone, all we have to do at this point is divide by your log. So I'm going to divide by log of 1.014 and divide by log of 1.014. If you kept the whole entire thing inside of your parentheses, you'll get x to equal 12.5. This study started in the year 2000. This is happening in the year of 2012. That is your answer. It doesn't happen at 13. It happens during the year of 2012. So you could say in 2012, I reach 8 billion people. The next question says the period and phase shift for the trig equation are what? So to find period, you have to do 2 pi over b. What is your b value? Well, this is a, this is b, and this is c. B is the 5, so you get 2 pi over 5 as your period. Now, your phase shift is if you move up or down or left or right. Now, inside, we have a minus 4, minus pi over 4, and that minus pi over 4 means that your function moved right pi over 4 units. Find the equation of a line that passes through the points 5, 2, and negative 3, 6. So you basically want to fill in y equals mx plus b. The first thing you're going to do is find your slope. To find slope, you need the equation y2 minus y1 over x2 minus x1. It doesn't matter which order you do this as long as you do it in the same order. So if I make this x1, y1, and this x2, y2, that means that 6 minus 2 is going to go on the top, and negative 3 minus 5 will go on the bottom, giving me 4 over negative 8. Reducing that to negative 1/2, that's your m. So, with y equals mx plus b, I'm going to replace the m with negative 1/2 x plus b. Now at this point what you want to do is solve for your b value. And to do that you're going to pick either of these points. I'm going to pick 5 over 2. But if you use the other one, you'll get the same answer. So I'm replacing y with 2 because that's what y is. And I'm going to replace x with 5 because that's what x is. Okay. Now at this point, you have negative 5 over 2 plus b. To solve for your b, add the 5 over 2. Okay, these cancel out. And you're left with b equal to 4.5. Or you can state 9 over 2, because that's the same thing. So your answer is y equals negative 1/2 x plus 9 over 2. Next question asks you to graph a piecewise function. So you have 3 pieces to graph in this case. Alright, so when you get started with this, break it up into parts. I'm going to do the table for x plus 1 first. And if you look at this, it wants you to do x is less than or equal to 1. So your table will have 1 and anything less than it. So 1, 0, negative 1, negative 2. 1's going to have a closed circle because it is equal to up here. And the rest of them, you'll just follow with your line whenever you fill in the points. So go to your calculator, plug in this function into y equals, and to get the absolute value, just press math and go to num and press abs and just put x plus 1. The table will give you your values, but you should know that these will get you 2, 1, 0, and 1. Alright, so now just graph these points. So I'm going to plot these values on my graph. So 1, 2, so I got 1, up 2, and then 0, 1, and then negative 1, 0, and negative 2, 1. We can go past on the left, but not on the right. The right stays at that point. So that's your first piece of your piecewise function. The next piece will be from 2, the second one. And 2 is being told to graph from 1 to 3. where 1 has an open circle and 3 has a closed circle. And these connect. You're not going to go past those points at all. Now, when you type this in, you should know first of all that if you have a constant, all the values are going to be 2. And when you graph this thing, well, the first point you have to graph is 1, 2, but there's already a point at 1, 2. So really, all you're doing is just nothing at that point, just leaving it because you know that it's right here. I'll put it in blue, but the point's right here. Okay, it would be open for the record, but because it's already closed from the other point from this function here, it's going to be closed. Alright, so then 2, 2, and then 3, 2. And you're just going to connect these. Okay, and everything's closed. Now the last one is the tricky one out of all of them. And the reason why it's tricky is because you have a fraction. 1 over x minus 3. First of all, they want you to graph this when x is greater than 3, 4, 5. Don't include 3 because it's not equal to. Now, if you put this in your calculator, and if you do, make sure that's in the denominator with parentheses, you'll get an error message at 3. And the reason why is because you cannot put 3 in the denominator because that gets you 0. That error just means that at 3, there is an asymptote. So on your graph, you can actually draw the asymptote with dotted lines. And then the other values are 1, 0.5, and you kept going, you get 0.6. Now looking at your graph, you can definitely plot 4, 1, 4. 4, 1 is right here. Okay? And you should know the shape of this thing. You really don't have to plot any more points because you should know that it goes like this and like that. Okay? And this is your graph. Now the next question says, is this continuous? And you should know that this is absolutely not continuous because there's a discontinuity at 3. At 3, there's an asymptote. So you have an asymptote at x equals 3. Okay, so the next question says, if g of x equals x plus 4, x minus 1, find the inverse. Okay, so to find the inverse, you're going to switch x and y, which you guys should know how to do by now. So you're going to have y equals, to start, x plus 4 over x minus 1, switch x and y, and at this point you're going to try to solve for y. Cross multiplying is a good first step. So you get x times y minus 1 equals y plus 4. Okay, distribute this, and you get xy minus x equals y plus 4. Now here's the deal. You got two y's. My suggestion is to bring those y's on the same sides. This would be minus y and minus y. Now at this point what you have is xy minus y equals 4 plus x. And you should say to yourself, well, how can I get these two y's here to be 1? And the answer is GCF. There's a y here, take that out, you're left with x. There's a y here, take that out, you're left with 1. Now to get y alone, just divide by x minus 1. And your inverse, which is g of x, g to the negative 1 of x, is equal to 4 plus x over x minus 1. That's your answer to part A. Now your part 2 is saying prove that this is an inverse, that you did it right. And the way that you can do that is one of two of the composition of function rules. I'm going to pick the first one and show that this equals x. So the way that you do this is you take the original and you're going to put the inverse in for x. So wherever you see an x, you're going to put the inverse. So now what I'm going to have is 4 plus x over x minus 1 plus 4 is going to stay there because it's part of the original. And then I'm going to replace the x in the denominator with 4 plus x over x minus 1. And then minus 1 from here. Okay, so at this point you want to reduce this thing. And in order to do that, you're going to use the x minus 1 from the denominator and multiply everything by x minus 1. And what happens here is that these cancel out, leaving you with something easier to reduce. So the numerator is all this stuff here. So I have 4 plus x plus 4, x minus 1. And then on the bottom you have all this stuff, 4 plus x minus 1 times x minus 1. Okay, distribute these in, and you're left with 4 plus x plus 4x minus 4 all over 4 plus x minus x plus 1. And what happens is that the 4's cancel, the x's cancel, and you're left with 5x over 5, and these cancel, and there's x, and that's what you had to prove. So good. They are inverses. Alright, so for this problem, what you're going to do is solve for x, and the way you're going to do it is utilizing logs. Take the log of both sides to bring down the power. This will bring these powers down, and leaving you with 3 plus x times log of 7 equals x times log of 5. Now this is very similar to the inverse question that we had because you're going to want to distribute the log, ending up getting 3 log 7 plus x log 7 equals x log 5. You want the x's to be together so that you can solve for x. And what this allows you to do is now that the x's are on the same side, you can pull out or factor out the common x. And this is equal to 3 log 7. To get x alone at this point, just divide by log 5 minus log 7. And that's what x equals. X equals 3 log 7 over log 5 minus log 7. You cannot reduce anything because of the subtraction on the bottom. Alright, for the next question it says, determine whether this is even, odd, or neither. Now, to do this algebraically, what we're going to do is plug in a negative x. If it was odd, you would get negative f of x out, meaning that the whole function would be negated. And if it was even, when you plug in negative x, you would get the same exact thing out. Okay, so meaning that for this thing to be odd, the whole top has to be a different sign, or the whole bottom has to be a different sign. Meaning that this would have to be negative and positive, or this would have to be negative and positive. Can't be both, only one of them. For it to be even, all the signs would have to be the same exact thing as this, or they would all have to be completely switched up. So let's find out what this thing is. If you plug in a negative x, you get this set up right now. So when you plug in a negative x, this becomes positive, and this becomes a positive x to the 4th, positive x, because this is an even power, it'll be positive. This is going to be negative, and then this will be positive x. Now, what I said before was that if this was odd, only one of the top or the bottom would be completely changed. If you look at the bottom is completely changed. This positive up here, the positive x to the 5th turned into a negative x to the 5th. And the negative x here turned into a positive x. But the top is also changed, which we don't want for an odd function. Only the top or the bottom has to be changed for odd. So let's think even. Well, they're not matching, so that's not the case here. And even if I changed all of the signs to be negative and positive, that doesn't match here either because this isn't negative. So this is considered a neither function. It is neither even or odd. And if you graph it, it kind of looks like this, and there is no symmetry at all. So we definitely know it's neither. Always try to justify your answer graphically. Now for this function to be odd, let me go over this again. Your original function is x to the fourth minus x all over x to the fifth minus x. For it to be odd, that means that one of two cases should have happened. Either the top would have been completely changed, keeping the bottom exactly the same, or the top would have stayed, changing the bottom completely. And that is not what we had at all. So it wasn't odd. For it to be even, it would have had to been exactly the same as it started, or it would have had to had every single sign switched. And if every single sign is switched, basically nothing has changed and nothing is different because you're just multiplying the top and the bottom by a -1, but you're really not changing anything to the function, because if you pull out the -1, right? You pull out the -1 here, essentially these cancel out and you start off with the same exact thing that you had. Alright, next question. Find the exact value of sine cubed pi over 3 minus cos fourth pi over 4 over cotangent pi over 3. Now you do have to know the exact values, so either memorize that 0.866 is radical 3 over 2, and 3. And that 0.707 is radical 2 over 2. And then I think radical 3 is about 1.7, or you can memorize that chart that I showed you guys, because you do want the exact value. Now, for the first part, what you want to do is find sine of pi over 3. Sine of pi over 3 is just radical 3 over 2, and you're going to cube that, minus cos to the fourth of pi over 4. Find cosine of pi over 4. That's just radical 2 over 2 to the fourth. Now cotangent is really 1 over tangent squared of pi over 3. So I can rewrite this now as radical 3 over 2 cubed minus radical 2 over 2 to the fourth. It's going to be 1 over whatever tangent of pi over 3 is, all squared. Tangent of pi over 3 is radical 3, and that's going to be squared. So you're going to just simplify this now. You're going to end up getting 3 radical 3 over 4 over 8, because 2 cubed is 8, minus 4 over 16. So you take the fourth of radical 2, you get 4, and if you take the fourth of 2, you get 16. All over 1 over 3. Now what I suggest doing is cleaning up the top, and you're going to do that by multiplying this by 2 over 2. So you get a common denominator, so you get 6 radical 3 over 16 minus 4 over 16 over 1/3. Combine the numerators, so you have 6 radical 3 minus 4 all over 16 all over 1/3. Now to reduce this even further, keep change flip, so 6 radical 3 minus 4 over 16, change flip, distribute this in, and you end up with your answer of 18 radical 3 minus 12 over 16. Alright, next question says, if a substance has a half-life of 25 years, how long will it take for 8 grams to decay to 1.4? This is a regular growth and decay factor. Okay, so you have a half-life, so that means that your B value is 1/2. X represents the amount of half-lives you're going through, and A represents your initial substance. A is 8 in this case. You want to know how long it will take for it to get to 1.4. So Y is 1.4, and you're looking for X right now. But remember, X represents the number of half-lives. So when you solve for this, divide by 8. These cancel. When you divide by 8, you get 0.175 equals 1/2 to the X. To get the X down, take the log of both sides. This comes down. and you're left with log of 0.175 equals x log of 1/2. Divide by log of 1/2. And I actually think it's best to change that 1/2 to 0.5 just so you don't mess up with the division and the fraction in your calculator. And when you do that, you get x equals 2.5146. Keep that whole thing in your calculator. This is the number of half-lives. You don't want that. You want the total number of years. It takes 25 years for one half-life for this thing. So multiply this by 25, and you end up getting your answer of 62.864 years. And that's that. I hope this helped, and I'll see you guys tomorrow. Study hard for your test.